viewers, and you are welcome to MLT channels. This is Engineer Oladipo, your host and your amiable online tutor. Today's subject is mathematics and the topic is trigonometry. You are welcome on board. So without wasting time, let's quickly dive into details. And today's learning goal is derivation of the cosine rule. In order to derive the cosine rule, we will need a triangle. So let's get a triangle. That's a triangle. Let's give it a stroke. Then turn the color to white. Oh, that's good. That's cool. Then let's bring it here. Let's enlarge it a little bit more. All right, perfect. That's good. Then let's name our triangle. Let's name it triangle ABC. So this should be A, while there is B. Then let's make the top to be C. Good, perfect. Now let's drop the altitude of the triangle. Okay, that's good. I'm trying to put that on 90. Okay, still not on 90. Okay. Let me undo that. That's not perfect. Okay, that's okay now. Okay, perfect. That's the altitude of the triangle. Let's name that the altitude of the triangle. That should be the height of the triangle. Then the side where capital letter A is facing, which is line CB, would actually be small letter A. While the side where capital letter B is facing, which is line AC, that will be capital letter B. Okay, that's not good enough. Let's write that. Okay, that's perfect. Then the base AB, the altitude has divided the base AB. So let's call this point D. Then if this is the base is ADB, then let's name side AD as X. Then if AD is X, what do you think side DB will be? Okay, let's try and get that. The entire base of the triangle is line AB, which is equal to line AD plus line BD. Now substituting the values, the whole of line AB actually represents small letter c, which is where C is facing. Then line AD, we have declared it to be X, while line BD, okay, this shouldn't be BC, that should be BD, which is what we are looking for. That's a mistake from there. All right, corrected, perfect. Okay, so line BD, which is actually what we are looking for. So making BD the subject of the formula now, that implies that line BD will be equal to C minus X. Okay, that's perfect. So that implies that line BD here is actually C minus X. So with this, we are now good to go to start writing to start proving our cosine rule, how to derive our cosine rule. Then in doing that, We will first consider triangle in triangle BCD. Triangle BCD. Okay, let's enlarge that. Okay, that's good. Okay. Okay, let's extend this a little bit. So in triangle BCD now, and there is actually our triangle BCD. Look at this triangle. That's triangle BCD. So in that triangle now, let's apply Pythagoras theorem. And if you are applying Pythagoras theorem states that the longest side, which is the hypotenuse side, and this is the hypotenuse side, line CB is the hypotenuse side, is equals to the sum of the square of the other two sides. That implies that our hypotenuse side, oh no, I don't want to use that. I'm not using the highlight, I'm using the mark actually. Okay. That implies that the hypotenuse side, its squared, is equals to the sum of the square of the other two sides. And the other two sides are the height, which is h, and the base, one of the base, which is c minus x. So putting all that, so we have a squared equal to h squared plus c minus x all squared. And let's call this equation 1. Okay, so what do we have to do on this equation? There's a slight problem here. So we have to expand this c minus x all squared. We have to expand that. So doing that, we are forming equation 2. A still retain its position. So we have a squared. Oh, that square isn't good enough. Let's rewrite that. All right, perfect. A squared. Oh, that's good. So it equals to h squared still remain in its position, plus, then this is where the problem is. We split it into 2. So we have c minus x, then bracket open and close, into c minus x again, into bracket open and close. There's no big deal there. Don't be nervous. We just split it c minus x in equation 1 into 2. Then going that, we actually need again in equation 2, we need to expand this. We have to open the bracket, remove all of bracket. So in doing that, a squared still retain. Okay, I'm not using that. I'm using the marker. So a squared still retain its position. So we have a squared again equal to h squared also retain. Then we multiply out c multiplied by c. Okay, plus that gives us c squared. Then c multiplied by minus x, that gives us minus cx. Then minus x multiplied by c, that still gives us minus cx again. Then minus x multiplied by minus x, that gives us plus x squared. And if we call this equation 3, then there is, what do we observe in equation 3? Simplifying our problem, we can see that these are like terms. Oh, no, not that. Okay, we can see that these are like terms. C minus x, c minus cx minus cx, those are like terms. So we can actually add them. Then in doing that, a squared still retain its position. So we have h squared equal to h squared plus c squared, then minus cx minus cx, that gives us minus 2cx, then plus x squared. Then we call this equation 4. Then in arriving at the problem, what can we do in equation 4? We can rearrange these terms in equation 4. This is the first, the second, the third. This fourth term, oh, I'm not using that. I want to use the highlighter. So this fourth term, which is actually x squared, we can bring it to the top term since it has squared, just like h and c. So in doing that, that implies that we still have a squared again, still retain its position, equal to h squared, then plus c squared plus x squared minus 2cx. Okay, so with this, we are done with triangle BCD for now. We now have to move to the other triangle. Okay, that's cool. All right. Again. Okay, that's cool. So now we want to consider triangle A, C, and D. So in triangle ACD now, okay, let's highlight that. That's cool. Okay. So in triangle ACD now, and here is our triangle ACD. Here is our triangle ACD. Here's triangle ACD. So in triangle ACD, we are also applying Pythagoras theorem, and we are doing that. Here is the longest side, line AC, which is equals to B is the longest side. So applying Pythagoras theorem in triangle ACD now, so we have B squared equal to H squared plus X squared. Then let's call this equation 6. Now, observing vividly, you see that the value of B in equation 6, which is H squared plus X squared, is actually present in equation 5. In equation 5, we have H squared plus X squared here also. So we can substitute this H squared for X squared as B squared, because in equation 6, B squared is actually equal to H squared plus X squared. Okay, so that means we need to perform a substitution now. So we say substituting equation 6 in equation 5. Okay, isn't like that. Good, perfect. Okay, that's okay. So substituting equation 6 in equation 5. Then where is our equation 5? Look at our equation 5. Here's equation 5. Here's equation 5. So if we put that now, so you have a squared equal to, then let's rewrite equation 5. So we have h squared plus x squared plus c squared minus 2cx. This is equation 5. So now, this is now what we are bringing in. We are bringing in this value, which is b squared instead of h squared plus x squared. So that implies that equation 5 now turns to h squared now. Instead of writing h squared plus x squared, we write b squared equals to b squared plus c squared minus 2cx. So let's call this equation 7. Okay, so what can we do with equation 7? We have to substitute for x. X is odd. Then in doing that, we go back again to oh no, I don't need that. We go back again to triangle ACD. So we are going back again to triangle ACD, and it's, this time we are applying SOHCAHTOA. And in the SOHCAHTOA that we are applying, we are interested in x. So we are considering x, which is and h. So that implies that to consider s and h, the Pythagorean's function that we are going to use will be car. So our angle theta will be here. Let's place our angle theta with respect to the horizontal here. So where nothing is actually facing is our what's it called? Where nothing is facing is our adjacent. Okay, not h that we'll be considering. It is x and b. Okay, let me clean that. Okay, here's our h. Let me also clean this. Let me clean this. Okay, good. So we consider that b isn't good enough. Let's write that. So we consider x and b. So that should give us a cosine function. So cos theta equals to adjacent x over what's it called? Hypotenuse, which is b. So say cos theta now equal to adjacent, and adjacent is x over hypotenuse. Hypotenuse is b. So if we make x the subject here, then x now will be equal to b cos theta. And let's call this equation 8. And we are almost there. So the next thing we just have to do now is just to substitute the value of x in equation 8 into equation 7 here. So we are bringing the value of x here in equation 7. Then that should give us our final answer, which is the equation of cosine rule. And in doing that, equation 7 becomes a squared now is equals to b squared plus c squared minus 2bc cos theta. And that is the final answer. Question easily done. So we have been able to derive the cosine rule. And here is the cosine rule. Okay. Here is the cosine rule that we have just derived. A squared is equals to b squared plus c squared minus 2bc cos theta. And that theta is actually cos A. Okay, I need to correct that. Yes, because this angle theta is actually angle A. So let's correct that. That should be cos A. So cos A, because that angle is formed at point A. So this should be cos A. Okay, that's perfect. All right, 20 minutes just gone down like 20 seconds. It's been so fun, so engaging, so exciting being here. Then you can watch more of our videos. Go to youtube.com at oladepo2262. Then you can connect with us in all our social media platforms, on Instagram, on Telegram, on Facebook, and our handle is at oladepo or you can come to our head office. Our head office is at Omega Building, opposite Gasland Nigeria Limited, Obafemi Awolowo Way, Malete, Ibadan. Or you can reach us via our telephone number, and my hotline is +234 80 670 76871. Or you can use our website, and website is www.mlttutors.wordpress.com. Book us for home tutoring, online tutoring for your words preparing for external exam such as SSC, UTME, Post UTME, IGCSE, School of Nursing, Common Entrance, Baker, etc. At MLT, we are rooted in sound values, driven by academic excellence, and building the future with qualitative learning and digital literacy. Until I come your way again, I remain my humble self, Engineer Oladipo, your host and your amiable store. Bye for now.